Something with me for just a minute. When you were probably in 3rd or 4th grade, combinations, I can distinctly remember this sitting as long ago as that was. I can remember doing combinations in elementary school. Combinations are where you might say you have 5 shirts and 7 pairs of pants. How many different outfits can you make with the, you remember, I just remember seeing, I can close my eyes and see the shirts that the teacher would draw on the board. This one had stripes, this one had polka dots, and this one, so you could see the different, okay, so that's combinations. How many different ways can you arrange something, okay, or can you do something? So we use it a lot with probability. Think about a deck of cards. How many different ways can you get a full house? Okay, or how many different, are y'all familiar with cards?
Yeah.
Full house is 4 of the same.
So in a deck of cards, you have 4 suits, right? You have diamonds. How many cards are all together in a deck of cards? 52. 52 cards. We're not talking about jokers or anything like that. 52 cards. You have diamonds, clubs, hearts, and spades. How many of each of those are there? 13. There you go. 13, right? 13 of each suit. You have different colors, right? What are the 2 colors? Red and black. How many red?
26.
How many black?
26.
Did you say how do y'all know this? Everybody does it. That's why I'm writing them on the board. Face cards. All right, so let's see. We got kings,
Queens,
jacks. I'm going to put aces down here. Those are not face cards, but I'm going to put those because we might do something with that. How many kings are there in a deck? 4. Queens. 4. Jacks. 4. Aces. 4. Face cards. 16. Right? Yes. Y'all follow me? Yes. All right, so take out your calculator for just a minute. Where did that thing go? It's been a long spring break.
It wasn't long enough.
Let's say I have a deck of cards. Okay? 52 cards, right? And I want to know how many cards do you draw for poker? Normally, okay, but at the end,
it depends. 7.
You have different ones.
Let's do 5 card draw. How about that? Let's say 5 cards at the end. You have 5 cards at the end. My question to you is, how many 5 card hands could you form that were made up?
Don't say all the cards. That's a blood load.
Made up only of kings. No. Only face cards. Only face cards. How many ways could you get hands? No, because I could have the king of hearts, the queen of spades. You see what I'm saying? I could have all these different combinations of hands. Okay? So how many different 5 card hands are there made up of only? So we use what we call combinations. Okay? It's the formula. I didn't expect you to get the answer to that. We're going to use our calculator for that. So what we do is we use this little formula where N is our total number of choices and R is how, because the N and the R are subscripts. How many we want. I feel like that whenever I get back from the break. It's hard to get back from the break. All right. So, and this, I'm hesitant to give you the formula for it. You don't have to know this, but I will give you the formula. The formula for combinations. Oh,
exclamation point question.
No. What is that? Somebody knows it.
An upside down eye.
No, what's... Y'all have never heard of factorial before?
No. Just erase the whole formula. I know. I used to live with that.
exclamation mark in math is a factorial. That means if I have 5 factorial, then that's 5 times 4 times 3 times 2 times 1.
Wait, so NCR.
Now, listen. You need to know what that is because that shows up on standardized tests a lot. Okay? So recognize it for what it is. Your calculator will do it for you. Under math, there is a factorial, but you're not going to have to plug into this. Your calculator will do this. But just because I don't want to not show you. I think it's under...
I do not see it on that.
I don't see it all.
There it is. It's under probability, number 4.
Oh, it's number 4.
Hey,
the formula is short.
It is. That's what I said. You don't even have to know this whole formula. I just didn't want to not show it to you so you know where it comes from. All right, look. So the question, going back to the question, how many different ways you want a 5-card hand? How many different ways can you draw a 5-card hand that's only face cards? Right? So there's a total of how many cards? But I'm only looking at face cards. 16. Of those 16, how many am I drawing? Come on. 16, choose 5, right? I'm not talking yet about probability. I'm just saying how many different hands are there using that number of cards. So if you take out your calculator, Corbin is right. If you look under math and you go over to the probability, you see option number 3 is NCR. Okay. The first one is NPR. That's permutations. That's whenever order matters. In other words, like if I said the first card, I want the first card has to be a king, the second card has to be a queen. Like the order that I draw them in matters. Combinations, the order's not mattering. All right, so the third option here, but here's what you have to do. Before you choose that, you've got to put the little 16 in first. So you do 16. No, it'll do that for you. Hit math and do the NCR. And how many am I choosing? Would you have thought that? Out of 16 cards, there's 4,368 ways to draw 5 of them.
Yes.
Because we'll stop it.
You can shuffle like a billion times.
I don't even
still
think
run through the same order of cards.
It's, yeah.
Brain and
But we're not even talking about order, Joseph. That's the thing, is we're not talking about, thank you, Silas. We're just talking about the hand itself. Two kings and a queen and... Hold on. This is amazing to me. How many different hands, 5-card hands, can you draw from an entire deck of cards?
Let's see.
Let's try. Dave and I agree. Let's see. This is fun. How many different hands, 5-card hands, can you draw from an entire deck of cards? Like, how many different hands are there? What am I doing? 52.
Math, probability.
Choose. That's a lot, y'all. So now let me ask you this. Now we get to the good stuff. What's the probability? Ooh, how do you do probability?
The equation you showed us?
It's a ratio.
It's a ratio of what?
100.
A what?
Over 100.
Well, but what's the ratio made out of to start with? Look, possible out of total, right?
yeah.
So if I said, what's the probability that whenever you get dealt a random hand, that you get 5 face cards, right? The probability would be, how many hands are there that you could get all face cards? And we're going to do a whole section on probability, but I just can't not mention it because it's so cool.
I'm totally gonna use
Out of,
odds next time I play poker.
it really, I mean, it's odds. It is. That's what it is. 2, 598,960. Now here's where you multiply by the 100 to get the percent if you want it. But 0.17% roughly chance of getting all face cards whenever you're dealt a hand of cards. That's not very good odds, right?
Wait, how?
Yeah.
0, 0, 1.
If you move it over 2 places times 100, if you make it a percent.
Why do you move it over 2 places then multiply?
No, you do one or the other. Multiplying by 100 is...
Multiply it by
1 over 595.
No. Multiplying by 100 moves the decimal 2 places. We start talking about a little more complex scenarios than just 5 face cards, or 5 any cards, or 5 red cards, right? Instead, we start talking about some things like maybe I want... I don't know all the hands. Let's say you wanted,
What is it?
You said 5 cards?
I don't think it's called three matches.
Queen X.
Straight.
You got straight. You have a lot of straight.
Mine can't learn.
So straight would be like 4, 5, 6, 7.
how many different possible hands you can draw if you need 1 ace and 2 kings, and how many do I have left? That's 3, and 2 other cards. How many different ways can you do that? Now here's what you have to think. These are different scenarios, right? The key to these is to remember the word "and" is going to mean to multiply, and the word "or" is going to mean to add. Okay? So how many different 5-card hands can I draw that consist of 1 ace, 2 kings, and 2 other cards? Okay, well, for the 1 ace, and I'm not talking about probability yet, I'm just talking about how many different hands are there. How many aces are in a deck? 4. And I'm choosing 1. And means multiply, right? 2 kings, how many kings are in the deck? 4. How many am I choosing? 2. Now it says and, which means multiply, 2 others. So I need to take the aces out, I need to take the kings out. How many are left? 46? And how many of those 46 am I choosing? I don't know, I didn't do it. 4 and 4 is 8. 52 minus 8 is?
44.
44.
And how many am I choosing? 2.
So it's probably
Now it should be fewer numbers than just 5 random cards, right? Because I'm specifying one of them's got to be an ace, 2 of them's got to be a king, and then the other 2 are just random cards from what's left. What's 4 choose 1? 4. What's 4 choose 2? What is 44 choose 2?
946.
What happens when you multiply all of these together? 20, say it again.
Yes, sir. That's how many
That's
possible
over
hands. 704.
What?
704.
Oh. Thank you. One more scenario to talk about before I bring this into Pascal's Triangle.
CLT, baby.
This is a loaded lesson, I'm telling you, and then we got 2 more big things to talk about. Do what?
Was this equation that we're about?
Not yet, no. All right. let's see if you really understand. I want to know how many 5-card hands I can make that have at least, ooh,
What about
at least 3 hearts. So, okay, so let's set the scenarios up. At least 3 hearts means I could have 3 hearts. Okay, you're exactly right. 3 hearts and 2 others. I'm going to put an O. Well, I'll write others. The others I'll just write H and O. That's right. I can. This hand satisfies. Or, right? Because that's a hand. Or I could have 4 hearts and 1 other. Are y'all following what I'm doing here? Nope. Okay.
And that's how you.
What? At least 3 hearts means 3 hearts or 4 hearts or 5 hearts. You've got to draw 5 cards. So so there's 3 scenarios that fits it, right? So 3 hearts, but if I have 3 hearts, that means I have 2 that aren't hearts. Or I could have 4 hearts, but if I have 4 hearts, that means there's 1 that's not a heart. Or I could have 5 hearts and 1 that's not a heart. Right?
No.
Oh, and the 0. I'm sorry. 0 O's.
That means you do something add it to something.
That you're exactly right. This is going to be a plus. This is going to be a multiply.
So it'd be 3.
All right, so how many hearts?
Wait,
How many hearts are in the deck? 13? 13. Choose how many? 3 times. If you take the 13 hearts out, 39. I think this is cool. I like doing this. 39, choose 2.
And 0 over?
Yes.
Plus 4.
13. Uh-huh.
Oh my goodness.
Got to have 5 cards in the hand, right? So you're making it up with what's left. Plus, but if you did it as probability, if you said you want to know the probability that you get at least 3 hearts because for whatever reason you need it,
Where's 39 coming
how many cards are not hearts?
from? Okay.
Well, this is just going to be 1. Because I haven't related it back to Pascal Triangle. That's always only 1 if it's 0 then. You could if you're multiplying, but if you're adding, you want to make sure you include it. That's why I wrote that on the board for you. I'll give it to you. All right, so what's 13? Choose 3. 2 what? 286. What's 39? Choose 2. Ooh, wait.
Yeah, okay.
What is 13? Choose 4. 39, choose 1. Are y'all seeing the pattern there when that's 1? What's 13? Choose 5. 1,287. Oh no. I didn't do it. And then 1. All right, multiply them and add them and see what you come up with. I'm ready to get to the Pascal Triangle part. And then the expansion part. That's fun too. I told y'all before we left when I showed you Pascal Triangle, it was the tip of the iceberg.
Daddy, I did not hear that.
We were going to work with Pascal's Triangle extensively. Did y'all get it yet? Do, 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 do. What'd you get, Chandler? 200 what?
Palmer, we did this now?
I didn't do all that. I just put it all together. So.
Is that what everybody else got?
Yeah.
I got you.
You make housing right for
150. Yeah.
Let me ask you this then. I wish I had a piece of candy to give the first person got there. I don't have any candy with me. What's the probability that you get a hand that is at least 3 hearts?
I'm about to show you right here, watch it.
100% you're going to get those cards.
Wait, so you do that?
What?
Are you for it?
Yeah.
Give me about $10. 47.
Yeah, I got some random numbers.
16. And then you multiply that number,
Oh, I don't know what that is.
and then divide by 3.
Isn't it 87? Wait.
Do it in your calculator.
9.3%.
Mine too does the practice.
You should have an approximation button.
There's non-probability.
We'll get to a probability section. Don't worry if you don't understand that just yet.
Wait, hold on. I'm still doing
I just can hardly do combinations without probability.
I'm still.
Oh, it's so cool. All right, so I'm gonna put a little bit of Pascal's Triangle up here. Okay, 1, 1, 1, 1. What's this number?
2. 3.
Y'all give me the numbers. Come on. 1,
4, 6, 4, 1, 5, 10, 5, 1.
Hold on, I have mine right here.
one more row. You don't need it.
1, 6, 15, 20, 15, 6, 1.
Okay.
We need to write this down.
1.
You need your Pascal's Triangle reference for this. Okay.
So we need to write this.
I want you to do something for me. I want you to take your calculator. Thank you, Palmer.
Well, no, like, I'm just not good with this kind of stuff. Do I need to write that down?
This is one we did a minute ago. What is 4 choose 2?
Is it 3? No, it's 6.
It's 6, right? Somebody, I really, really, really want somebody to find this pattern as we
I got it. No, I think I got it.
look at it. Look at it. Look at it. What is 5 choose 3?
Don't calculate it.
Hold on, I can find out.
Is it 10?
It's 10.
Hold on.
Oh, I got it, McGee. I got it.
Look here. 4 choose 2 is 6. 5 choose 2 is 10.
You're exactly right. You're exactly right.
Yeah, my boy.
If you remember everything in Pascal's Triangle starts with 0, right? This is row 0, row 1, row 2. This number indicates the row number, okay? That's your n. Okay, and then count over this many, but starting with 0. So 4 choose 2. Here's row 4. 0, 1, 2. 5 choose 3. Row 5. 0, 1, 2, 3. What is 6 choose 4?
15.
Yes.
Chill, boy. Hey, look.
So, on your test, you will have a huge Pascal's Triangle that you have to fill out. Fun, right? And then I will say, using Pascal's Triangle, find the following combinations and highlight them in your triangle so I know that you're using the triangle and not your calculator.
Wait, how do you
Hold on.
explain how you do this again?
All right, so you've got NCR, right? This is the row. But remember, you have to start at 0. And this is how many over you go. So I go to, for this one, I go 6th row. The second number tells you which row you're on. 6th row, and I need to go over 4. But remember, Pascal's Triangle always starts with 0. 0, 1, 2, 3, 4.
Why can't I just use that? So ain't that something like that?
Well, you could, but what if I asked you 52 choose 5? You don't have 52 rows on your Pascal Triangle. But isn't that cool though? That it's become a-
Yeah,
So you go 0, 1, 2, 3,
So
4.
you always start with 5 as well.
Yep.
Wait, do it, explain it one more time. I'm sorry, I really,
0,
yeah.
1, 2, 3, 4.
You all can-
Goodness.
Wait,
So wait, hold on.
What you gonna do?
Yes.
Is that the one?
Sometimes I think y'all see something really simple and you're just so used to things being complicated that you're
No,
like,
alright.
wait, what's the catch?
Hold on, do the 5 and the 3 equals 10 one.
All right, look. Row 5.
Okay.
Okay, here's row 5. Count over to 3. 0, 1, 2, 3.
See, like, that's why Aristotle was not really that smart. You just told him like the most simple things.
This was Pascal. Corbin, I know you understand. You showed us this. Okay, let's get to the hard part.
Miss McGee, we only have 45 minutes.
Wait, so
We only need 42 to do it. No, I'm just kidding.
This would you say you top that top one is counts as 0.
Mhm.
And then the leftist one.
Pascal always starts with 0, row and column. I used to have a poster in here, Pascal poster.
Even the dead person running that.
All right, let's do binomial expansion.
is our homework gonna be on Pascal Triangle?
Some, yeah. You really want, keep your Pascal triangle that you have written out. Keep it handy. You'll need it for your homework. And you'll need it for what we're doing. I don't know why this thing keeps jumping. You should have at some point, I'm thinking. If you don't, go ahead and write one out so you have it. I would take it up to, let me pause this so I can write one on the board. Gave you something like, that, and I asked you to expand it. Okay? Remember, you can't multiply more than 2 at a time, right? So you'd have to do a plus 2b times a plus 2b. You'd have to FOIL that out, simplify it down, then multiply it to a plus 2b again, right? FOIL it, simplify, multiply it to a plus 2, and you have to do it 5 times, right? So Pascal's triangle, this is so cool, can help us to expand it without actually doing all that, and there's a pattern to it. If you go to this row in Pascal's triangle, okay, now remember we start with 0. So what is row 5? Yes. It's going to be a formula, but it's a little easier for me to show you in the example. It's
No, it's 1 with a 4.
It's 1, 5, 10, 10, 5, 1. Right? 0, 1, 2, 3, 4, 5. It's the second number tells you the row number. Yeah. Okay? These numbers in that row are going to be the coefficients when this is expanded. Okay? Now here's what we do. Just watch. This is going to be good. You have to see it a couple times, but once you pick up the pattern, it's not bad. You take 1. Okay? I'm going to do because I don't want y'all to look back at your book and get confused. We're not going to do it with combination. All right, so we take the 1. We take the first term, which is a, and we're going to raise it to this exponent. Then we're going to take the second term and raise it to 0. Now, yeah, it is, but I did that for a reason, you'll see. The next one we're going to do, we've already used this, we're going to take the 5, okay? The first term, and here's what happens. This exponent counts down, this exponent counts up. So when I get to the end, they will have swapped places, okay? So this becomes 4, and this becomes 1. Exactly. Then it would be, but you got to use your coefficient here. So then it's 10, and you're right, it's going to be 3, 2. Okay. The numbers in front are coming from here. The exponents are coming from, this is the first, the second is 0, and we go down, up. The first one's counting down, yep. In the very last term, this one will be 0, and this one will be 5. Okay? I have another 10. What is my coefficient here? 2. Plus 5. What are my exponents? My coefficients. 1. Yes. I have one more. I don't think I'm going to be able to squeeze it. 1. A 0 to B 5. Look at the exponents. They have now swapped places. Okay? Now, I'm not done with this.
So what does this hold me?
Now what I have to do is simplify as I go. This is the hardest part of it, okay? Because you got to go order of operations. So the first thing that I have to do is each term, I got to do the exponents. You're exactly right, okay? And because this second one has a 2 in front of it, it's going to impact that a little bit, okay? So this first term is easy. Somebody said at first that's 1, and that's right. So that's an easy one to simplify. This is just a to the 5th, right? Plus, I'm going to take this in 2 steps so you see what's happening. I've got 5a to the 4th, but I've got to multiply that to 2b. Yep. Plus, I'm going to mark this out because I start to lose my spot if I don't. I start getting, because it's long. All right, 10a cubed, but I've got to multiply that to 4b squared. The good thing about this is you won't have any like terms to combine. You're only simplifying each term in between the pluses. Okay? 10a squared times what?
8b. Well, 8b. All right, cool. 5.
That's right. 5a. Uh-huh.
4.
A to the 0 is 1. So I've just got, Now it's easy multiplication. I just multiply the numbers there, right? First term does not simplify, so it's just a to the 5th plus 10 a to the 4th b plus 40 a cubed. That's right. And then the 32 states. I know that that looks like a lot, but I promise you, it is not as much as multiplying that out by. And that's your answer. And that's your answer.
That's the whole answer?
That's the whole answer. If you FOILed and multiplied and combined like terms in the end, that's what you would come up to.
That's a really good
I want to do one more with you that has, beside which 4? 40. Why does it keep doing that? 40. Yes.